11.3, defining radians. Suppose we have a circle that has a central angle. The radian measure of the angle is the ratio of the length of the arc defined by the angle to the circle's radius. That is, theta is equal to arc length divided by radius. So we've seen this ratio several times now. We've seen it as lowercase l over lowercase r, uppercase L over uppercase r. We've calculated this ratio several times, and we're always getting it in terms of pi. So we're going to try and keep that in mind as we go through this. All right, so this is really just a new type of measurement. If you remember on your calculator, when you go to mode, you can switch between radian and degree mode. So we have been sticking in degrees. But now we're going to talk about radians, since you can also measure angles, and the circumference of a circle can both be expressed in radian. And that makes sense because we earlier in the unit we talked about arc length, the measure of an arc, like say from here to here, being a certain number of degrees. So if it can be measured in degrees, it can also be measured in radians. So let's investigate a little deeper exactly what this new form of measurement is. Okay, so number one, the image shows a circle with radius of 1 unit. A, cut a piece of string that is the length of the radius of the circle. So I've got a piece of string here. I'm going to cut off the end because it's a little curved there, a little frayed. I'm going to try and be as accurate as possible. All right. Put my finger down on the center and hold it out. Really, this is a two-person job. We'll try and do it as one person. You can, of course, experiment with this on your own as well. Let's see, how did I do? It's close enough. Okay. Use the string to mark an arc on the circle that is the same length as the radius. So I'm going to start from this endpoint here of this radii. Basically what they're saying is line up the string on the circle, and they chose a string, not a straight edge, because you can't bend a straight edge, so that it follows 1 unit along the circumference of the circle. So it looks like it's stopping right about there. So we can also say that, now let me get a straight edge for this part, for this arc, that this arc here is also 1 unit long. C, draw the central angle defined by the arc. So that's this angle here, let's call it theta. That's what we normally use to represent angles we don't know the measure of. So now they want us to use our definition of radian to calculate the radian measure of the central angle we drew. Well, according to this problem, the way we calculate a radian is by taking arc length and dividing it by the radius. So if I'm trying to find radians, that's going to be equal to my arc length of 1 divided by my radius of 1, or just 1. So theta is equal to 1 radian. Basically saying that the central angle theta, as it extends to subtend an arc, that arc is going to have the measure of one of the radiuses of whatever the circle is. If the circle has a radius of 6, this would be 6 inches. If it was 9 centimeters of a radius, then this would be 9 centimeters long. So instead of saying it in degrees, we're just saying it in radians, which is nice because sometimes maybe we don't know exactly what it is in degrees, although we could figure that out from this problem since we have the radius. Okay. 2. Draw a 180-degree angle, a diameter, in the circle. Use your 1 unit piece of string to measure the approximate length of the arc defined by this angle. So I'm going to extend my radius to make it a diameter, and I'm going to take that piece of string again. I'm going to try and see how many of these can fit and the circumference of a semicircle. That one ends right about there. That's another 1 unit, altogether 2 units. Start from the same spot. And we get about here, it's another 1 unit. Now this little piece at the end here, it's going to be a little bit tougher. Let's see exactly how long this is. This is about 1.4, 1.35 inches. And this is like half an inch. I don't know. Let's say it looks like maybe like 0.2 of a unit. Looks like maybe like a fifth of this whole, maybe a little bit less, like, let's say maybe like 0.15. Somewhere between a tenth and 2/10 of the entire thing. Okay, so let's add up all these units together. So 1 plus 1 plus 1 plus 0.15. And that looks like to be about 3.15 units, which should look somewhat familiar to a number you've seen before. Definitely in this unit. All right, but let's actually figure stuff out mathematically. Calculate the radian measure of the 180-degree angle. Give your answer to both in terms of pi and as a decimal rounded to the nearest hundredth. So we can actually find the circumference of this, right? This is just an arc length, a fraction of a circumference. So I know if I'm using a 180-degree angle, right, that's going to be my central angle. Semicircle is 180 degrees. So theta is equal to that, and my radius is equal to 1 unit. So since this 1 unit is pretty much already in radians, right? Because that's what a radius is, 1 unit. So now when I make my formula for arc length, I've got theta over 360 times, talking about circumference, right? So 2 pi r. All right, I want to find my length. I know the angle is 180 out of 360. And I know my radius is 1 unit. So 2 times pi times 1. And again, we're trying to find arc length here, if that's not clear. Sorry, I don't know if I made that perfectly clear. Because in order to calculate radians, we need arc length divided by radius. I don't know the exact arc length because this is an estimation, right? Couldn't tell you exactly what that was. So now I'm going to actually try and find it perfectly in radians. Okay, so simplified is really 180 over 360 is 1/2 times 2 times pi. Anything times 1 is just itself, so I can sort of ignore that 1. 1/2 times 2 is just 1, so really what I'm left over here is pi. Now they want us to also round that to the nearest hundredth, so I go to my calculator, I plug pi in, I get 3.14159. So I can just round that to 3.14, which is very, very close to what we got here. So besides saying that this arc is 3.14 units, we also want to find out how many radians it is. And since our radius is 1, that's a very simple conversion, right? If we have arc length over radius length, 3.14, or really pi if we want to be accurate, and we always want to be exact, and the radius is 1. So it's pi units over 1 unit, and that's just equal to pi radians. All right, so radians, in some cases, you almost want to imagine that the radius is equal to 1, because that's what they're really trying to drive home here. And if that radius is equal to 1, if you divide that arc length by whatever that radius is, that'll give you your radians for that arc measure. Okay, calculate the radian measure of a 360-degree angle. Well, we already have the measure for 180, right? I've got a circle, and I know that halfway around the circle is pi radians. It's going to take another pi radians to get to the other side of the circle. So pi plus pi is equal to 2 pi. And 2 pi is equal to 360 degrees. So that is a very, very important measurement we have in geometry. 2 pi is equal to 360 radians. As long as you memorize this one conversion, you can pretty much do any degree measure. If I want 90, for example, and I don't know the number of radians, well, anytime you have two equations, you can also make two equivalent proportions. So I can say that 2 pi over x is going to be equal to 360 over 90. Cross multiply just like we did in our similarity unit. 360 times x and 2 pi times 90. So we get 360x equals 2 pi times 90. Really the same as saying 360x is equal to 180 pi. So I multiplied 2 and 90 there. And now let's divide by 360 to get x alone. Always leaving it in terms of pi, especially when we're talking about radians. Radians are always in terms of pi. 180 divided by 360 is just 1/2. So that's equal to 1/2 pi, or just pi over 2. Some of you may have been able to do this quicker. Some of you may have been like, oh, well, if I divide 360 by 4, I get 90. Well, if you divide 2 pi by 4, that's going to be equivalent to pi over 2. Let's say I wanted 45 degrees in terms of radians. Well, if pi over 2 is 90, I just divide 90 by 2 to get 45. Pi over 2 divided by 2, or times 1/2, those mean the same thing. It's just going to be pi over 4. Another one that you will commonly see, or often see, 30 degrees. Well, if I know that 90 is pi over 2, 90 divided by 3 is 30. So if I want to take pi over 2 and divide it by 3, or just multiply by a third, I get pi over 6. So these are the types of radian measures that you really want to get familiar with. 30 degrees, pi over 6. 45 degrees, pi over 4. 90 degrees, pi over 2. 360, 2 pi. You know, we just talked about 180 being equal to pi radians. 270. It's going to be 3 pi over 2, or 3.5 pi radians, right? 270 over 360 equals 3/4. So 3/4 of 2 pi is equal to 6 pi over 4, or 3 pi over 2. That's where we're getting that measure from. I know this is a lot. Dealing with fractions is not always fun. Dealing with a new unit of measurement can be a little bit confusing. But as long as you remember this first one here, 2 pi is equal to 360, you can find every single other one of these. Just say, oh, if I have 90, what am I dividing 360 by to get 90? Right? Following that pattern. But you will 100% see these on the SAT. We had to memorize them when I was in high school, but I don't know how necessary it is other than the SAT. But you will definitely use them. If you want to give this bonus a shot, are you ready for more? I will give extra credit for that. Do a little bit of research. Maybe make a small little 5-minute presentation. Happy to give extra credit and show the rest of the class that. All right, have a good day.